Hi, welcome to this video session. In this video, we are going to see the magnetic particle inspection and radiography inspection method.
Non-destructive testing, magnetic particle inspection. The magnetic particle examination is an excellent method to investigate near-surface defects in ferromagnetic materials. This video shows the basic principle and the practical procedure. The material tester gets the machine ready for use and inserts the test piece between the two poles of an electromagnet. Then she takes a bottle with a suspension of magnetic particles, turns on the electromagnet with a foot switch and applies the suspension of magnetic particles onto the test piece. Already in daylight, dark lines are visible on the surface. The lines can be seen much better under ultraviolet light and particularly well at darkening the daylight. The suspension contains pigments that cover the magnetic particles and fluoresce under ultraviolet light. The particles run off in areas free from defects and they are attracted and clustered near defects. This workpiece shows a whole array of cracks. The basic principle is to magnetize a ferromagnetic workpiece parallel to its surface, as shown in the sectional view. If the workpiece is free from defects, the magnetic field lines run within the workpiece and parallel to its surface. In places of magnetic inhomogeneity, for instance near cracks, the magnetic field lines will locally leave the surface and a leakage field occurs. Now, if a suspension of ferromagnetic particles is applied onto the test piece surface, the magnetic particles will run off at defect-free areas. In places of leakage fields, the magnetic particles are attracted and clustered together, thus indicating the place of the defect. The method works best using a pigment which covers the magnetic particles and shows fluorescence under ultraviolet light. Even cracks can be detected that are not open to the surface but just below it, as long as they are not too far below the surface. But one precondition must always be fulfilled. The magnetic field lines must be perpendicular, or at least at a certain angle to the defect. Otherwise there will be no leakage field and the defects remain undetected. Our test sample has been magnetized in horizontal direction. The magnetic field lines run horizontally. This is the reason why cracks in vertical direction are visible particularly well. To make sure to detect all near-surface cracks, one has to magnetize the sample once more and best perpendicularly to the first time. To do this, the material tester switches the machine over to the current flow method. A high electric current flows through the sample, generating a circular magnetic field. Now the cracks in horizontal direction can be seen very well. The tested sample is a hardened sliding guide. The cracks have been formed during the hardening process and the subsequent grinding operation. Still another test piece has to face the magnetic particle inspection, a section of a large gear wheel. The same procedure again. Placing the gear wheel between the magnetic pole pieces, magnetizing and applying magnetic particle suspension. Already in daylight, there are indications of cracks, and again, they are best visible under ultraviolet light while darkening the daylight. The visible cracks are so-called fatigue cracks. They have been generated during the operation of the gear drive due to a mismatch of the gear wheels.
short video will show the method of radiographic testing inspection by using gamma ray radiation source. There are a lot of techniques of RT inspection. In this short video we'll show some of these techniques which inspect by using single wall single image technique, panoramic technique, double wall single image technique, double wall double image technique. The equipment and tools are gamma ray source system, radiographic films, cassettes, and intensifying screens, lead markers, IQI, penetrometers, weld specimen, magnetic stand, safety gear, exposure calculator. First of all, we'll show the inspection which is using single wall single image technique. This technique is applicable for both plates and pipes. Primarily intended for pipe diameter of 100 mm and above, where access is permitted. The procedure is: after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place the film underneath the plate. Place the lead letters. Set the source at right angle with the film and weld seam using magnetic stand. Set the specimen at a proper distance. It should be more than minimum distance that you can calculate it by the rule. Calculate the exposure time by application. Process the films inside the darkroom. The second technique is panoramic. It should be performed for pipe of outside diameter from 12 inch. The procedure is: after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place the lead letters. Wrap the films around the welded pipe. Set the source at the center of the pipe using the magnetic stand. Calculate the exposure time by application. Process the films inside the darkroom. The third technique is double wall single image. It should be used to radiographic pipes of 3.5 inch diameter and above when internal access is not permitted. The procedure is: after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place letter F, which is mean film side. Because of the other technique is source side, wrap the films around the welded pipe. Place the source at an angle of 10 degrees far of the cap of the weld as you see. To take the film from inside. Calculate the exposure time by application. Process the films inside the darkroom. The fourth technique is double wall double image. It should be used for pipe has equal or less than 3.5 inch of diameter. A technique can be used in which the radiation passes through two walls. The procedure is: after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place the lead letters. Calculate the required geometrical unsharpness factors for both superimposed and elliptical techniques. Wrap the films around the welded pipe. Set the source at right angle with the film and weld seam using the magnetic stand, and be careful to place the specimen at a proper distance. Calculate the exposure time by application. Process the films inside the darkroom. However, these techniques have a lot of applications and different guide in the detection of defects while compare them with each other. Because every technique has a special situation and limitations.